we're not going to be doing chemistry for several weeks. The fact is that we're going to have to focus in on some of the more fundamental introductory stuff so that we know that we're all on the same page before we can go on to chemistry. So one of the first things we're going to have to do, one of the earliest things we're going to have to do, is deal with this idea of measurement. We're going to have to measure stuff. In chemistry, if it's not measured, then we really don't know that much about it. Okay? So how do we measure? The first target we're going to look at is just what units do we use to measure. That's targets 2.1. I can distinguish between English, metric, and SI systems of measurement. All right? What is SI? SI stands for Système International. Okay, what language is that? French, right. What if I had said it this way? Système International. German. What if it was beautiful like this? El Sistema Internacional. No, this would be Italian. Sistema Internacional. I mean, if an Italian person has his hands cut off, I mean, are they mute at that point? Isn't that great? Italians talk with their hands. That is awesome. All right, Système International was developed by the French back in the 1700s, probably to avoid a war. Okay? What was going on back in the 1700s? A lot of international trading. But the problem was that people wanted measured amounts of stuff, and when they got to where it was being exported to, it wasn't the measured amount that they were expecting. So people got angry with each other. People started threatening, and this is after Napoleon. So after Napoleon, the French really they got into cooking. And French fries and French toast and stuff like that. They didn't want, no more wars. Okay, so they said, no, don't get hot on it. Don't get mad, no more wars. How about if we come up with a standard way of measuring stuff? We shall call it the meter. And the English said, meter. We can handle that. And the Germans said, meter. Oh, no, I don't know German. Just make sure you got a lot of phlegm when you're speaking German. There were two countries initially that basically said, no, we're going to do it our way. And Canada. Not as much. Are you Canadian, eh? Then why did you... Oh. Oh. No, they put maple syrup on their French fries. What kind of weird is that? I mean, French fries need ketchup, not maple syrup. That's just weird. Canadians are weird. So we went to Canada back a few years ago, and what we found, of course it's called Canada. What? And if you're from Canada, what are you? Canadian. Ah, we're not Americania because we're Americans. America, Americans. Canada, Mexico. No, you're confusing things. Okay, so I went to Canada several years ago, and I got so excited. See, in America, gas was like $2 a gallon. I got to Canada, and it was $1 a gallon. Yes! I was pulling this big camper, and I got really excited. First time we got some gas, I'm going, $1 a gallon, $1 a gallon. And it took twice as much money. And I go, oh no, what did I not realize? They had already switched over from gallons to liters. And it takes about 2 liters to make 1 gallon. So it wasn't $1 a gallon, it was over $2 a gallon. And then I'm sitting there, it was cold, it was the middle of June, and the temperatures were in the 70s. My children were everywhere has heated pools because it's too cold during the summer. So they're there enjoying a heated pool. The next day we were going to go to Niagara Falls. It was already kind of cool. So my wife comes up to me after watching the TV. She goes, guess what temperature is going to be tomorrow? I go, what? It's going to be in the 20s. And I freaked out. And she started laughing because we didn't bring any jackets. And she started laughing, and she made fun of me, saying, you're a chemistry teacher? I go, Celsius, isn't it? She goes, yeah. So the Canadians have already switched over. We're the only ones that use the F word when we're determining temperature. So, can you imagine going from one state to another and a gallon is different amounts? That could get kind of confusing. So we don't do that. We don't do that. Why will we be using the SI in chemistry? Because pretty much all the scientists, except for engineers, engineers still like to use a lot of English units, but pretty much all scientists use SI. It's just easy to communicate with people all over the world if you're using SI. Good example of the fact that engineers probably should have switched over to SI is about 20 years ago, the first Martian lander that we sent, we think, crash landed into Mars. Everything was all right until they got close to Mars, and then we lost it. So they started trying to figure out what happened. And they found that, well, there were multiple companies that worked on this Martian lander that helped contribute different components to it. And most of them used SI. Yes, most. What's the problem? Most. Not all the companies used SI. Some of the companies, at least one company, used English units. So they think that the difference in units confused the computer, and the computer couldn't handle it, so it just crashed itself into the Martian. So, yeah, something as silly as using different units is what caused a multi-million-dollar spacecraft to crash. So now now they're really, really careful with this. Why is SI better? Foreign people like Marieli understands it, because a metro is the same in Mexico as a meter here in America. A meter, same length. Subunits are all in base 10. I still have trouble remembering whether it's 4 quarts to a gallon or 2 quarts to a gallon. Half the time I think it's 4. Well, that's correct, right? 4 or 2? Okay, good. The other time I mess it up and think it's 2 quarts. So, but in the metric, everything is in base 10. Look at this. Look at all the different subunits. Everything is 10 apart, or some multiple of 10. I like this diagram because it kind of reminds me of my life. Back when I was a kid, back when I was your age, I had my first computer. 256 kilobytes of RAM. Okay, 256 kilobytes. That's 250,000 bits. Oh my, bytes. I'm sorry. That's not a lot. Now these days we measure, well, for most of my adult life we've measured in megabytes. Now we measure in gigabytes. Actually now you can get a hard drive fairly cheap that's in terabytes. And there's even one beyond that, petabytes. Petabytes now. Okay? So your kids will deal beyond peta. So. Base units, derived units. Base units, derived units. Base units, derived units. What's the difference between a derived unit and a base unit? One is based. What? No, they all have numbers. The end? Oh, you mean the little threes, the subscripts? Okay, that has something to do with it. No. No. Base, You are trying. Nope. If what you're trying to measure, like area, requires 2 base units. I mean, think about area. What's area? Length times width. What do you measure length in? Meters. What do you measure width in? Meters. So area is meters times meters. That's a derived unit. So if what you have to do is take base units and multiply or divide them, then what you've done is you've derived a unit. You've derived a unit. Okay? So area, volume, speed, density, those are all derived units. Because in order to get them, we have to take 2 or more base units and do something to them. Right? Does that make sense now? Derived. Base. For example, the most famous one of them all is volume. Volume is length times width times height. What really, we call it different things, but it is just length times length times length, isn't it? And length is measured in meters. Meters. It's not meters. I'm being consistent. If you're going to use meters, then you need to be consistent. Marie, what do you measure? What instrument do you measure? You want to use meters, right? You want me to call it meters every time. Okay. What instrument do you use to measure your temperature? A what? A thermometer.
Oh my God.
A 5K race is how many? What distance? No. What distance is it in SI? What distance is it in SI? Kilometers. That's right. But most people say kilometers. No, kilometers. I don't care. They're Europeans. It's America. That's all we care about. All right. So I say meters because I'm just trying to be. I'm trying to be consistent. That way, I get to say thermometer, kilometer, centimeter, decimeter.
That's not how you say it.
Decimeter. Decimeter. Volume is length times width times height. That's meter times meter times meter, or centimeter times centimeter times centimeter, or decimeter, decimeter, decimeter. Okay, so it's cubic centimeter, cubic decimeter. These are, if you're wondering what the difference between SI and metric, this is it. This centimeter and decimeter is SI. We use the metric system a lot. Milliliters and liters. They're similar, but they're not exact. For example, Celsius is metric. Kelvin is SI. So in many cases, they're the same unit. In some cases, they're not. So volume is the most important derived unit. You're going to have to take the length, width, and height of an object. It's measured with a graduated cylinder or a burette. Here's a good illustration. 1 cubic meter has how many decimeters? It would be 10 times 10 times 10. 1,000. You see, these are cubes. So it's not just 1 10. It's not 2 10s. It's 3 10s. These are 3 10s apart. So there's going to be 1,000 of these cubes in this 1 cubic meter cube. How many of these teeny tiny little centimeter by centimeter by centimeter cubes are there in a decimeter cube? 1,000. Because these guys are 10 apart, right? But not in the cubic world. In the cubic world, they are 10 times 10 times 10. Okay? Understand? No? There are 10 centimeters in a decimeter, right? But in the cubic world, it would be 10 times 10 times 10. 1,000 in there. There are 1,000 in there. There are 1,000 of these tiny little cubes in there. I know. It was hard for me to understand. You will. The best thing about chemistry is that it's one of those things that keeps repeating itself until eventually you understand. Graduated cylinders. Hey, do you guys remember meniscus? It's the lowest part of the curvature, right? Here's a young lady using a burette, this long tube. That is the most precise way of measuring volume. Balance scales. That's very precise. I'll explain to you why later. Okay, we won't use those. Why? Because druggies like those, they'll steal those. They won't steal these. Triple beam balances. This requires too much intelligence for them. They don't want it. They don't want it. This is too much work. They have to go to school for this. So triple beam balance is what we're going to be using. That doesn't get stolen. That could get stolen. We have one of these. This is so exact. It goes to the thousandths of a gram. This is so exact that it actually has these little doors that slide on because a gust of wind, me talking near it, could cause it to become very. Here's some other units. Pressure, energy, force, speed, area, amount. Yeah, we're going to use the mole. Have you ever heard of mole day? Oh yeah. We'll get to see what some of you guys look like before 6:02 a.m. Oh yeah, mole day festivities is going to be fun. Okay, fine. Just don't get extra credit points. In chemistry, we will use the metric system, Celsius, or we will use the SI Kelvin. We will not use the F word. And if you use the F word in this class, I'm going to write you up. I'm going to put down, Molly used the F asterisk word. And the administrator will know that she used the wrong unit for temperature. Celsius or Kelvin, not the F word.